So we're going to review solving equations, and more specifically, we are going to solve exponential and logarithmic equations. So some of this is review, some of it might be new, but either way, if you feel overwhelmed, then stop this video and you can go back and watch the Math 3 videos that you did in a previous course. There's nothing wrong with that if you need extra resources. Alright, so we're going to solve exponential equations using a common base first. Number 1, we're going to rewrite the equation using a common base. 2, we're going to use the properties of exponents to simplify each side of the equation. Number 3, we're going to use the one-to-one property. So this is if b to the x equals b to the y, then x equals y. So if you can understand that, so the bases just cancel out and then you just set the exponents equal to each other. And then we're going to solve. Okay, so here's the first thing we're going to do. Number 1, notice that they both have a common base of 3. So we're just going to skip down to the third step. And when that happens, you can cancel out the bases, and then the exponents just equal each other. That is nice when that happens. So now all you got to do, you get rid of subtracting 9 by adding. And then you get rid of multiplying by 2 by dividing. So x equals 8. Done with that one. So if I look at the next one, pretty much the same thing. So notice all 3 of these have the exact same base. Alright. So remember that so this is back from Math 1. We're going to use the properties of exponents. If you had like x to the second power times x to the third power, you would actually add the bases. So we're going to use that exact same rule. So notice over here, these two are being multiplied. So I'm going to combine them by adding the exponents. So c plus 4c, 3c is 4c. I keep saying the answer, sorry. And negative 1 plus 2 is plus 1. Alright, so I did number 2. I used the property of the exponents to simplify. Now number 3, I'm going to use the one-to-one property, which says if my bases are exactly the same, then I can cancel them out, and then I can just set my exponents equal to each other. So that's what I'm doing. I'm going to move this up a little bit, and now I'm just going to solve. So I'm going to move the 4c over by subtracting. So I have 1 equals 3c plus 16. I'm going to get rid of the plus 16 by subtracting. And then I'm going to get rid of the multiplying by 3 by dividing by 3. So I get that c equals negative 5. Alright, so those first two were easy because they had a common base. The next set doesn't have a common base. So the first thing we're going to have to do is we're going to rewrite it so that it has a common base. So here's what you do. This is the smaller one, so I'm going to leave it the same. 81, think about what to the power of what equals 81. So if you think about 9 squared is 81. So now that I have rewritten this, I can use the one-to-one property because the bases are the same. I can cancel them out. And now I can set the two exponents equal to each other. And then solve. I can get rid of subtracting 26 by adding. So 4y equals 28. And I can get rid of 4 by dividing. So y equals 7. Okay. The next one, I'm going to do pretty much the same thing. They don't have the same base, but I can manipulate it until they do have the same base. So 2 is my smaller number. I'm going to keep that one the same, equals. I want it to be 2 to some power equals 32. So you can use your calculator until you get it. But 2 to the 5th power actually equals 32. The only thing to remember is to put the rest of the parentheses, the rest of the exponents in a parenthesis. Alright, so now my bases are the same. I can cancel it out. So now I have m minus 9 equals 5, parentheses, m plus 3. So now I have to distribute my 5. So I get 5m plus 15. I need to get my m's together, so I'm going to move this m over. So negative 9 equals 4m plus 15. Oh, that did not work out for me. Okay. Alright, and then I'm going to get rid of the plus 15 by subtracting. So now I have 24 negative equals 4m. And then the last thing I'm going to do is divide both sides by 4. So I get m equals negative 6. Okay. That was a lot. I went fast. You can rewatch that video as many times as you need to. Do it at your own pace. Okay, so now let's look at solving logarithmic equations. So the first thing we're going to do is we're going to condense the logs on each side of the equation. So the word log should only happen once is what it's saying. Number 2, I'm going to use the one-to-one property. So this says if they both have a log base b, then they can cancel out, and then x can equal y. And then we're going to solve and check for extraneous solutions. So this is a big word, but just think about extra. So that means anything that when you plug it back in, it doesn't work. Okay, so if we look at the first one, this is a log equals a log. They both have the exact same log base. All right, so we can cancel them out. So I'm just going to write what's left, and I'm going to solve that. So I'm going to move the 5x over. So I got 2x minus 1 equals 17. I'm going to get rid of the minus 1 by adding. So 2x equals 18. And then I'm going to get rid of the 2 by dividing. So x equals 9. So you can plug 9 back in and make sure it works. It does, just to save time. Okay. So let's look at the next one. Notice that the logs are already condensed. I just realized that I am missing a 1/2 in front of this log. Sorry, but they're right on your note sheet. I'm just not sure when I import them in why this program is like dropping some of the numbers. That's a big deal. Okay, let's try this. That looks better. It looks like yours now. Okay, so now, actually the one on the right side is not condensed. So remember, anytime there's a number in front of the word log, that can actually be moved to become a parenthesis. To become an exponent. Alright, so let me rewrite what we have. So log base 4, 4p plus 3 equals log base 4, 16p to the 4th, and now it's to the 1/2 power. Okay, so now the logs are condensed, that I don't have typos. They both have a log base of 4, so I can cancel those out. I'm going to write what's left. Okay, and I'm going to go ahead and simplify that 16p to the 4th to the 1/2 power. So remember, everything is being taken to the 1/2 power. So 16 to the 1/2 power is 4. Type that in your calculator if you don't believe me. Remember, anytime you do a power to a power, you multiply. So 4 times 1/2 is p squared. So I'm just going to replace this with 4p squared. 4p squared. Okay. So now I'm going to get everything to one side. So I'm going to move 4p over, and I'm going to move 3 over. So this is what I have. 0 equals 4p squared minus 4p minus 3. Okay, it would make my heart so happy if you realized that this was a quadratic and that you remembered that you can solve quadratics by factoring, by graphing, by doing blah, blah, blah. It doesn't make my heart unhappy if you have forgotten, because we're going to go over it, but if you don't remember how to factor and you're already in Math 4 and you've done it for 3 years, I'm going to just tell you, I want you to graph this in Desmos and tell me where it hits the x-axis. So I want everybody to pause the video, graph this, tell me where it hits the x-axis in 1, 2, 3. Okay, so the easiest thing to do when you get to a quadratic and you don't remember how to factor or the quadratic formula, blah, 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 put this in Desmos and click the buttons right here, and those are your two answers. So my two answers are negative 0.5 and 1.5. So P equals 0.5, which is the same thing as 1/2, negative 1/2. And then P also equals 3/2, which is the same thing as 1.5. Okay. That's really ugly how I wrote that. Someone change that. Negative 1/2. Okay. Alright, so let's look at what happens when there's a log equals a number. Okay, so for the ones for these, I think the easiest thing to do is to get the log base of whatever by itself. Alright, so I'm going to get rid of this minus 5, and I'm going to get rid of it by adding. So x plus 7 equals 2. And then, because it's just a log equals a number, I'm going to convert it to its opposite form. So notice this is already in log form. I'm going to make it into exponential form. So there's the base. There's what I'm taking the log of. There's my answer. So you do the base of whatever the log was to the exponent equals what you were taking the log of. So this is from that very first video that we did on this unit. You can go back and watch it if you need to. So 6 squared is 36. And I'm just trying to get x by itself. So I'm going to get rid of that plus 7 by subtracting. So 31 equals x. There's my answer. Oh, try that again. 29 equals x. Okay, alright. Embarrassing. Alright, so look at this last one. So we have 2 logs on one side of an equation. Anytime that happens, we got to condense. So notice that we are adding. We bring together at addition by multiplying. So the two things that I'm adding are n minus 3 and n plus 1. So I would multiply those two things together. Okay. So this is going to be multiplied together. You're going to FOIL, you're going to distribute. We're in Math 4, we should know how to do that. When you do that, you get n squared minus 2n minus 3. Okay? If you don't know how to FOIL or distribute, then you need to send me a message and come work with me one-on-one. Alright, so this is in log form. Here's my base. Here's what I'm taking the log of. And here's my answer. So now I'm going to convert it into exponential form. So the base of the log is 2. My exponent is now going to be 5. And it's going to equal n squared minus 2n minus 3. Okay, so now I can do 2 to the 5th power is 32. I should recognize that this is a quadratic. We want all quadratics to equal 0, so I'm going to move 32 over here. So I have n squared minus 2n minus 35. The easiest way to answer this problem is to graph that quadratic in Desmos and see where it hits the x-axis. So I'm going to let you pause the video and do that in 1, 2, 3. Alright, so when you graph this, it hits at two different places. X equals negative 5 and x equals 6. So since they're using n's, we'll just use n's. N equals negative 5, n equals 7. So I'm going to tell you that one of these solutions is extraneous and does not work. So you need to plug them back in into this original n and see which one doesn't give you 5. For instance, if I use negative 5, I'm going to do... my pen stopped working again. So log base 2, I'm going to plug in negative 5 to that original problem that we have. Log base 2, plug in negative 5. And so this should give me 5 if it works. So I'm going to put this in my calculator. And when I hit enter, I get non-real answer, which means this answer does not work. The only answer is right here. Okay. Okay, so that's what it means by an extraneous solution. Okay. Alright, so now let's look at solving exponential equations using logarithms. So number 1, we're going to isolate the exponential expression if we need to. Number 2, we're going to take the log of each side. Number 3, we're going to expand the logs if necessary using the power rule. And then number 5, we're going to solve and check for extraneous solutions. So remember, once again, that word extraneous, extra, anything that you plug back in and it doesn't work, you don't want to include in your answer choices. Okay, so the first thing is we want to isolate the exponential expression. So it's already isolated because there's nothing being added or subtracted, so we're good to go. Number 2, we're going to take the log of each side. So we're just going to write the word log on each side. That's all we're doing. Alright. Number 3, we're going to expand the logarithms using the power rule. So you can go back and look at the power rule if you forgot, but all it says is if you have an exponent, it's going to move to the front of the log. So I'm going to rewrite this. X times the log of 3 equals the log of 80. So now it's real easy to get x by itself because all I got to do is divide both sides by the log of 3. Alright, so I just got to type in my calculator log 80 divided by log 3, and then I'm going to round to at least 3 decimal places, so I get 3.988. Around to 3 decimal places, 9. Okay. Alright, the second one, pretty much the same thing. I'm going to isolate the log if I need to. Nothing's being added or subtracted, so I'm good. Now I'm going to log both sides. But remember, an e and a natural log get rid of each other. So I'm going to do natural log for both sides. So remember, natural log and e cancel each other out, so I have x equals natural log 140. And this is nice because it's already isolated. All I have to do is type this in my calculator, and I get 4.941. So let's do 2. Alright, so those are nice. Cool. Okay. Let's do the last 2 and get these over with. So the first thing I want to do is I want to isolate the log. So I have this extra plus 25. So if I want to isolate it, I'm going to subtract 25 from both sides. Alright, so now I have e to the 3x power equals 83. Alright, so I'm going to do the log of both sides. Because it's an e, I have to do natural log because that's what gets rid of a natural log. Alright, so a natural log and an e cancel out. So 3x equals natural log 83. The last thing I'm going to do is to get rid of that 3 is divide. So in my calculator, I'm just going to type the natural log of 83 divided by 3, and I should get 1.473. Alright, and then the very last one, I want to isolate the log part as much as I can. So I need to get rid of that negative 2. It's being multiplied, so to get rid of it, I'm going to divide both sides by negative 2. So 8 to the 4 minus x equals positive 25. So now I'm going to take the log of both sides. I'm going to use the power rule. Anytime there's an exponent, I can write it in front. So 4 minus x. I'm going to put that in parentheses just to remember that it goes together. Alright, so if I want to get rid of that log 8, remember it's being multiplied, I can divide both sides by log 8. So I have 4 minus x equals log 25 divided by log 8. I'm going to go ahead and put that in my calculator just to make it easier. So I get 4.58. And now I have to get rid of the 4. I'm going to subtract 4 from both sides. And then if I need to get rid of the negative, I'm going to, oh, that's a negative. I'm going to divide both sides by negative 1. Okay, So x equals 2.452. That's my answer. Okay, that was a lot. That was like a week's worth of a lesson in one because it is review. You have extra resources. You can go back. You can rewatch these videos as many times as you need to. You can rewatch the stuff from Math 3. You can do extra credit. Lots of stuff to help your grade out so that you don't fail. And then you can always ask me for help, and you can always ask some people in the classroom, start a study group, all that good stuff. Let me know what I can do for you.